A new Department of Energy-funded research project seeks to solve one of the biggest challenges with solar power: what to do with solar panels after they. Solar energy is key to solving climate change, but for the technology itself to be sustainable, it needs to be recyclable. Unfortunately, when a solar panel dies today, it's likely to meet one of two fates: a shredder or landfill. Arizona State University (ASU) researchers are hoping to change that through a new recycling process that uses chemicals to recover high-value metals in materials like silver and silicon, making recycling more economically attractive. Earlier this month, the team received a 2-year, $485,000 grant from the DOE's Advanced Manufacturing Office to further validate the idea, which they hope will lay the groundwork for a pilot recycling plant within the next 3 years. Matching funds are being provided by ASU and energy company First Solar, which is serving as an industrial advisor on the project. If all goes well, a cleaner and more cost-effective solar recycling process could reach the market right as the first wave of solar panels hits the waste. As we're ramping up clean energy manufacturing, producing more clean energy tech, thinking about recycling at the end of life becomes even more important, says Diana Bauer, acting deputy director of the Advanced Manufacturing Office at DOE. While relatively few solar panels have reached the end of their life already, experts suspect most of those that are winding up in landfills, where valuable metals and materials inside them are lost. Meng Dao, a solar sustainability researcher at ASU who's leading the new recycling effort, has estimated that the world could face supply shortages of at least one of those metals, silver, long before we've built all the solar panels needed to transition off fossil fuels. Solar-grade silicon, meanwhile, takes tremendous amounts of energy to make, and using it more than once is important for keeping the solar industry's electricity demands and its carbon footprint down. New solar recycling processes could improve the economics considerably. Even when solar panels are recycled today, these materials are rarely recovered. Instead, recyclers typically remove the aluminum frame holding the panel together, strip the copper wiring off the back, and shred the panel itself, creating a solar hash that's sold as crushed glass. Those 3 products, aluminum, copper, and crushed glass, might fetch a recycler $3 per panel, Dow says. Companies Dow has spoken with say it costs up to $25 to recycle a panel, after decommissioning and transit costs. New solar recycling processes that recover more metals and minerals could improve the economics considerably. Dow and his colleagues are proposing one such process, in which the envelope-sized silicon cells inside solar panels are first separated from the sheets of polymers and glass surrounding them using a hot steel blade. A patent-pending chemical concoction developed by Dow's recycling startup TG Companies is then used to extract silver, tin, copper, and lead from the cells, leaving behind silicon. While the recycling process uses harsh chemicals, Dow says those chemicals can be regenerated and used again and again, reducing the amount of waste that's created, a feature of his recycling method he believes to be unique. Dow adds that by recovering lead, the process also has the potential to eliminate an environmental hazard that would otherwise wind up in recycling waste or landfills. Dow claims TG Companies has already developed technology to recover 100% of the silver, tin, copper, and lead in solar cells. The new DOE grant will allow his team to further optimize the recycling process for solar panels and verify whether silicon can be recovered at a high enough purity to manufacture new cells without going through an energy-intensive purification step known as the Siemens process. If all goes well over the next 2 years, the next step will be to attract private investors to finance a pilot plant that can use the process to recycle around 100,000 solar panels a year. Karsten Wambach, the founder of solar panel recycling nonprofit PV Cycle, says that a green chemistry approach like Dow and his colleagues are proposing has a large potential to recover valuable secondary materials and contribute to protection of the environment. This high-tech trash could become treasure. But Wambach notes that recovering all of the silver and other trace metals in solar panels might not be fully achievable due to losses during the process of separating silicon cells from polymers and elsewhere. In a commercial version of this process, he says, the amount and quality of recovered metals will be optimized according to the downstream user's specifications and cost savings potential in the treatment processes. Cost savings will be key. Depending on the price of silver, Dow thinks his process could recover $10 to $15 of materials per panel. But that could change. Wambach warns, if manufacturers continue using less silver in solar panels over time, and even $15 per panel is unlikely to cover the full cost of decommissioning and recycling the panels, meaning supportive policies may be needed to scale up. A final hurdle, Wambach says, is that there just aren't that many solar panels being pulled off rooftops today. But while less than 500,000 tons of solar waste existed globally in 2016, the International Renewable Energy Agency has projected that by 2030, that figure could rise to 8 million tons. By 2050, we could be throwing out 6 million tons of dead solar panels every year, nearly as many as we're installing. Based on those projections and data on the value of metals and minerals inside each panel, Dow and his colleagues have estimated that by 2028 solar e-waste will contain over $1 billion worth of harvestable materials. For anyone who is able to crack the recycling challenge, this high-tech trash could become treasure. Top of comments.